Hi. Now that we've got some of the basics out of the way, data types, variables, statements and expressions, and the use of an editor, we can dive into conditionals. Conditionals are what start to make programming a little bit feel more like, well, doing something a little bit smart, a little bit clever, because you start to have to make your programs start to make some actual decisions. Before we can talk about conditionals, we need to introduce one new data type, which is a Boolean. A Boolean is a special data type that represents just the values true or false, and that's it. We can set a variable to be true and set another variable to be false. Notice these are not strings, there's no quotes around it. They're not numbers, right? It's a sequence of letters. And they have the special values, meaning true, which is the semantics of being true, and we'll be able to test if something is true or not true, or false or not false. Let's print out these values, print A and print B, and run this program, and at the bottom we'll see A is true, the first thing we printed, and B is false, the second thing we printed. Well, having these variables with this new Boolean data type doesn't do much on its own, but it starts to get more interesting when we can compare something, when we can compare Boolean values. And the way we do that is with comparators. A comparator is used to compare two different values. We can compare numbers and strings and Booleans. So, for example, the most common comparator is an equality comparator to let us compare whether two things are equal. We can print the result of saying is A equals to B. Now notice, this is a little bit tricky. Those are two equal signs in a row. This is not the assignment operator that you saw over here, which was a single equal sign. Two equal signs compares two values and returns true if those two values are equal and false otherwise. Here, let's get rid of these two print statements and run this, and we will see false. Is A equal to B? Well, since A is true and B is false, A equal B is false. These are not equal. If, on the other hand, B was equal to true, and we ran this again, then that statement, A equal B, would be true. We can use this equal comparator for numbers as well. We can say print 5 equal 7. Well, that's going to be false. We see in the bottom, it's false. How about 5 equals 2 plus 3? And we run this, and we get true, because 5 is equal to the value of adding 2 and 3. There are actually 6 comparators. Equal checks to see if two things are equal. There's also less than. So that returns true if the thing on the left is less than the thing on the right. When we run this, it will give us true. There is less than or equal to, so this will turn true if either the thing on the left is strictly less than the thing on the right, or if they're the same. Then there's greater and greater equal to. If we run this, we will get false. And finally, not equal to. So this will return true if the two operands are different. In this case, 5 and 7 are not the same, they're different, so this returns true, which we can see here. Okay, we've got our comparators. Now, it turns out we also can combine Boolean values by doing logical operations on them. For example, we know right now that A and B are both true. So if we want to compare A and B and ask whether they both are true, we can do that by saying A and B. So AND is an operator that takes two operands and it returns true only if both of its operands are true. In this case, A and B are both true, so A and B is true. If we set one of these to false and run it again, then it'll output false. Similarly, there's an OR operator. OR returns true if either A or B are true. So in this case, since one of them is true, A is true, when we run this, it will output true. Finally, we can get to something a little bit more interesting, which is we can use this new understanding of Boolean and conditionals, and comparators, to perform some logic and tell the computer to do something and do one thing in one case and another thing in another case. So let's start with something easy. And we're going to introduce an if statement. If is a special statement in Python. It takes a single operand, which must be a Boolean, at least it must evaluate to a Boolean, and if that thing is true, then it will execute the next set of lines. An if statement always ends with a colon, and now this is going to allow us to get past the idea of everything in Python being one line. Remember earlier I said that we get to the point where you can have multi-line operations. Well, an if statement ending in a colon affects the following lines, and it works as follows. When I press enter in this PyCharm editor, notice it didn't put the cursor back on the left side. It indented automatically, and I can say print hello. What's going to happen is it will only execute this line if A is true. So when I run this, it prints hello because A is true. If A was false and I ran it, it wouldn't print anything. If we go down here, and we go back to the left column, and we print end of program, and we run again, we'll see it prints out end of program, which shows that we did in fact get to the end of the program, but what happened here is the if statement ran, it evaluated A, found out that it was false, and so it didn't execute the next lines. So let's talk a little bit about what the next lines are. Why did print hello get skipped, but print end of program get executed? And the answer is because of this indentation. The if statement, as we'll find out, like a lot of Python statements, operate on the next lines that are indented. If you're familiar with other languages like JavaScript or Java or C, then this will be very unusual. In many other languages, there's an explicit delimiter, usually curly braces, that say when a special operation like an if statement starts and ends. But in Python, there is no explicit way to end the if statement. Instead, all of the lines that are indented following the if statement will get executed if the if statement evaluates to true. So, how about we enter some more things? Order some pizza. Print, I am hungry. Right? All three of these lines will get executed if A is true. Right now A is false, so when we run this, none of those get executed. If on the other hand I set A to be true, and we run it again, then all three of those lines got executed. Now we can start to use this new kind of logic to write a slightly more interesting program. Let's go back to our little banking situation and say that I've got $10. And now we can write a statement, an if statement. If money is less than 100. Now wait a minute. I said that the if statement takes a single operand, and here I've just typed in three things. Well, it turns out that those three things get evaluated first. Money is less than 100 gets operated as a single expression and gets interpreted as the value true or false. That whole thing turns into a Boolean. And then that Boolean value gets passed to the if statement. So if money is less than 100, then this will be true, and the indented lines after the if statement will be executed. So let's print, I am feeling poor. Now, I want to say if money is greater than, say greater or equal to 100, then print, I am feeling rich. if we run this, since money is 10, it will, the first if statement will be evaluated as true, and so it will print I am feeling poor. The second one will be evaluated as false, and it will not print I am feeling rich. If on the other hand we change our money to 1,000 and we run it again, now it'll change to say I'm feeling rich, because the first if statement will not run because that expression will not be evaluated as true, and the second one will. It turns out this is such a common style of programming to say, if something is true, then do one thing, otherwise do something else, that we don't have to write this as two separate if statements and then make sure we get this logic exactly right. Instead, we can just replace the second if statement with an else command. An else command in Python, like the if statement, must end in a colon, and then everything after the else statement that's indented will get executed only if the if statement is false. So in this case, if money is less than 100 is true, it executes the first, otherwise it executes the second. So this does exactly the same thing as before, but now it's a little bit semantically clearer because we can clearly see if one thing, do something else, do another. Let's look at one more example. Remember I said that the if statement takes a single Boolean, even though that Boolean might be the result of a richer expression. For example, I can put this entire expression in parentheses, and now it might look a little bit clearer that this whole thing is one thing that gets executed. But those parentheses really aren't necessary. Let's add another variable. Say I like to date. Actually, I don't like to date because I'm married, but suppose I did, and I had a date, or maybe I have a date with my wife tonight, and that would make me happy. So I'll say have date. So now we're going to change this program a little bit to say if I have money and I have a date, then I am feeling happy. Otherwise, I am feeling sad. So similarly, if this entire expression evaluates to true, then this top part will get executed, else, otherwise, this bottom part. So in order to understand this, we have to be able to interpret how this gets, what this means. And what we have here is an AND operator, an AND comparator, which takes two things, a thing on the left and a thing on the right. The thing on the left is this expression, money greater than 100, which evaluates to a Boolean. And have date is a variable, which is a Boolean. So this is perfectly fine legal Python. It might be clearer if I put parentheses everywhere so you didn't have to interpret the order of operations, the precedence. This does exactly the same thing, and it's a little bit clearer what the order of operations are. Now, what's this going to do? Well, money is only 10, that's not enough, so it's going to say I'm feeling sad. Presumably I don't have enough money to go on a date. But if I have more money, and I run this, then I'll be feeling happy.